that requires human intelligence, means that perform like computers. In simple terms, we can say that AI involves programming computer. We can program a computer, a robot to think and act like a human being. This can be such as we're learning from experiences, problem solving, understanding languages, and reasoning and thinking like a human. Whatever a human can do, a machine or AI can achieve that. So machine learning is a way for computers to learn from data that we give them and make decisions on that data without being programmed. It's like teaching a computer to recognize patterns and improve its performance over time and time. So one of the few examples of machine learning would be, there are devices you have heard of like Alexa or Siri. These devices, Alexa or Siri, use machine learning to understand your voice commands and improve their responses over time and time. Another example of machine learning would be websites like Amazon and Netflix. What are these? They use machine learning to recommend products or shows on your past behavior. So this is a typical example of how machine learning is involved in our daily life. In the next this slide, we can see this is basically a typical machine learning workflow, how machine learning works and how a model is created. And this is an end-to-end typical machine learning workflow. In the start, you can see we have a data collection. We gather a data and we pre-process that data. And after that, we select a model for our data. Then we train that model. And after that model is trained, we evaluate the model. If we get a high accuracy, we go with, okay, this model is deployed. If we don't get a high accuracy, we say the model is not okay. So we train the model again and again. So to improve its performance over time and time means like we have to train the model again and again to improve its performance. So this is basically a machine learning workflow. Like you give a model a data and it learns on its own with some mathematical operations. And if the performance is and accuracy is not that much, not that high, so we tell the model that you are not good to go, you have to be trained again. So by training again, we give the model more data, because in the beginning, the data was less. So the model couldn't be with a high accuracy, the model couldn't be deployed. So we have to give the model, we have to tune the model again. So to make it more accurate, because we need an accuracy like more than 90 above to get an accurate model. So basically, there are three functions of a machine learning system. This is descriptive analytics. This is the first one. This descriptive analytics looks at the past data and explains that what has happened. As you can see, in the beginning of this, we collect the data and we pre-process the data. In this pre-processing stage, we see the data, that what has happened in this data. Like I can give you an example. If I want to know that how many products a store has sold in the last month, this analysis, data pre-processing, this analysis, descriptive analysis will show me how it will provide me a deep report about this. What has happened in the past month. In the next, we would see a predictive analysis. It is used to predict what will happen in the future. Like it uses an historical data to forecast that what will happen in the near future. And you can get an example of this as you can see your weather app in your mobile, that it can predict your data, like what will happen tomorrow. Will it rain, or will it be a sunny day, or what will be? So the last would be prescriptive analysis. This analysis sees the data and it recommends some actions based on that prediction. The prediction we have made, now we have to make some actions according to this. So after predicting that data, like the example I recently gave you about the sales department. So after predicting that the sale will increase somehow of that store, so the it will recommend this prescriptive analysis will recommend to that store that your amount of this amount of data, its sales will be increasing in the future. So what you have to do, you have to grab that more amount of data, like you have to stock it up somehow. So these are some basic functions of what a machine learning system does. Why necessary in Python? Like, why is it necessary that we should do machine learning only in Python? Because we have a lot of other tools to do machine learning. Like we can do it on MATLAB, and recently TensorFlow, which is a Python library, has installed some is JavaScript function. But why is it necessary for us to do in Python? It is because of its simplicity and readability, because Python is a very easy to understand language. You can easily understand it because it has large extensive network of frameworks and libraries. Some of its frameworks and are like scikit-learn, TensorFlow, and PyTorch. These are like some necessary libraries which are used for machine learning. So Python is readily considered as an easy language as compared to other languages. So it is very simple to understand and simple to read. And the thing is platform independence, like it can work on any OS operating system, like whether you have Mac OS, Android, or Windows OS and Linux OS. And Python being the number one language makes it a very large and active community on the GitHub and any other thing. Like whenever you have a problem, you can search it up. Like it has a very active and large community which can help you to solve that problem. So these are some kind of 3 libraries which Python has. The one is scikit-learn. Scikit-learn. This is pronounced as sklearn something else. Python library. So it is used to, it contains like a lot of machine learning algorithms which are like supervised or unsupervised algorithm. And these algorithm are like the types of algorithm are like support vector machines, machine learning, and algorithm, random forest, k-means. Some of might you have heard. What this library does, it loads the data, then it splits the data into training, then it's train the model, and then evaluate the model. So sklearn, this library is one of the most important libraries for machine learning in beginner level, because it has like every algorithm that machine learning need. It directly downloads it from the net. So for the next thing, we have a TensorFlow. TensorFlow is basically a library. It's an open source library which is developed by Google. So it is used for machine learning and artificial intelligence. And PyTorch. PyTorch is also an open source machine learning framework which is developed by Facebook AI Lab. So TensorFlow is developed by Google and PyTorch is developed by Facebook AI. So these both are used for machine learning, and PyTorch is mainly used for deep learning. So basically, what we have 3 types of machine learning: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. What does these mean? Like when we see supervised machine learning is a type of a machine learning in which we have a data set, and that data set has labels attached with them. Like if we have a data named as age, or if we have a data named as any other thing like marital status, is he married or not, or like images, a data of images, and we have a label that is representing what that image or what that thing is, what that age is, what that all these things are inside the data. They have a label. So this kind of machine learning is called supervised machine learning. In this machine learning, we have like classification models. We can classify two things, and we have regression models. So like the types of regression and classification models are like logistic regression and others. So now we will see supervised machine learning in a bit detail. So this is the first example of supervised machine learning. It is basically a logistic regression, and it is used for like to solve a classification problem. Binary classification means it takes two values, either yes or no, either 1 or 0. Yes is represented with a 1 or no is represented with a 0. So like if for example, if we take a disease like an example, so we have to find out whether this person has a disease or not has a disease. So if he has a disease, that means it is a yes, and the yes is represented with a 1. If it does not have a disease, it is represented with a no, and no is represented usually as 0. In machine learning, everything is represented within like numbers. There is no like these labels or like these strings or these quotes. Everything is represented on the basis of a number that can vary from 0 to 1 only, not higher level. So the logistic regression has a value between 0 to 1. So we can see from this example, this is basically a visual workflow of how logistic regression works. So consider that logistic regression has two variables, independent variables and dependent variables. So consider these three things as like features. These are like features we have in our data set. We have an age, we have a smoking status, we have a gender. These are some independent variables slash features in our data set, which determines that this person will have a disease or no. So logistic problem is like we have a dependent variable. This is a dependent variable, and this is the outcome you are trying to predict. So I am trying to predict that based on these three factors, that the person will get a disease or no. So we can look into the data set. So this is a data set. In this, we have like three independent variables: age, gender, and smoking status. And we have a dependent variable known as disease. So in our data set, we can see that a person with age 20, this gender with this status does not have a disease. And a person with this age, this gender, and this status has a disease. So this is a random data generated. So we can see I have represented this data with F, F, and F, and this with T. The F means that this is a feature. This data set has a feature, and this is our target. This is our target too. We have to predict this thing based on these three things. So we can define a features. The features are defined as data with age, gender, and smoking, and the Y is the data, which is basically a target data, 0, 1, and 0. So a binary classification means that we have two outcomes. Either it is a yes or either is it a no. So we have to predict these two only. There is no third case that involves here. So independent variables are the features. These are the features that you are going to predict. So the logical function transforms. So it gives us like a value, the value between 0 and 1. There is no like we cannot get a value of points here because we want only these two values, 0 and 1. There is nothing. If the value is like less we cannot consider. We only consider the values between 0 to 1. But in the real world, the logistic function varies from plus infinity to minus infinity, but we only take these two values, 0 and 1. So moving on to the next thing. Unsupervised learning. This is basically a second type of machine learning. In this type, we don't have a label. Like we have the data, we have the input independent variables, but we don't have a dependent variable. So unsupervised learning is basically a type of machine learning in which we don't have a dependent variable. So this is an approach in which we discover patterns, structures, and relationship in that data that is not categorized. Like from the previous example, we can see that we have three features. The features were age, gender, and smoking status. But those three features will be presented in the supervised learning. But the dependent variable that there was like the disease, we don't have here. So detecting unusual patterns that do not conform to expected behavior. So we have like unusual patterns that data is not marked properly. As you can see from this example, that supervised learning was like we have two features, age and the another feature is like tumor size. So these are the person which will get the disease, which have a high chance of getting cancer, and these are the persons that don't have a high chance of getting cancer. So this basically there is a line mark which identifies the data that these belong to a different group of class and these belong to a different group of class because they are labeled. They are labeled as not getting cancer 0 and they are labeled as getting cancer 1. So in the unsupervised learning, we can see that we have these two features, input independent variables, age and tumor size, but we don't have this label data. We don't know which one has the cancer and which one don't have the cancer. So in this type of unsupervised learning, we used a different approach. We used an approach that is called as cluster to make a cluster of your data. This is a cluster, like bunch of our data is here and there's a bunch of our data here. We make different clusters based upon depending upon our data set. Then we verified with some distance learning approach and a clustering algorithm. They are like different algorithm designs designed for this. In the example, when we can see that we are given a data without any output labels. So there is no output. So if we have to predict a cancer prediction, we are not asked in this data that whether there is a tumor is malignant or benign, because we are not giving any labels. We are not given any labels. So our job is to find some kind of a pattern, like what are these pattern meant for, like what are these certain different pattern doing in it. Like these patterns, like the one I have shown you in a previous example, like this, like we have to determine these patterns, what are these people having in common and what are these people having in common based on a clustering algorithm. So to find what is interesting in this unlabeled data set, what are these people having? So we can see in a clustering example here, consider this as a DNA microarray, which has your DNA samples in it. So these are the individuals column and these are the genes row. So there is a cluster of data, like you have a cluster here, green color, and you have a cluster here, and you have a cluster here, black, and and another cluster here, red. We present data in a cluster in such a way that the similar points are placed together. Like these have some similar features, so they are placed in the screen, and these black one are like they have some similar features, so they are placed here, and this red one, they have some similar features and they are placed here. So as you can see, the red here might represent a gene that affects eye color. So that differentiates to this green one, which affects how tall someone is. So basically, we arrange data in such a way that this is different from another set. So you can run clustering algorithm to different types of individuals together based on categories the algorithm has decided. So this is some kind of a clustering algorithm in which you differentiate your data based on their similarities. So like if you have to find random data about any market or any store, that what are the people doing, what are they buying, and which type of people are coming at which slot. So these are like a different type of data that is not marked with people ages and people certainties, etc. So this is like a kind of example for clustering, and which lies in the unsupervised model. So a popular algorithm for it is k-means, but we will not go deep into this because this is like a high level algorithm. It takes a lot of time to understand this. So the third type we have is reinforcement learning. This is a branch in which we have agents and which we have environments, and we make our agents to make some of their decisions in that environment through trial and error. The agent then receives a feedback on what he has done, or some kind of reward or penalty, so it can achieve the best strategy. So to understand reinforcement learning in a better way, we can understand it from this workflow. This is basically a workflow of reinforcement learning. First, we define a problem. What is the problem? Then we create an environment for that problem. And after that, we choose an agent that will play in that environment and perform some set of actions. And when the set of actions are performed, they receive a feedback, and regarding that feedback, they update the policy. And after that, they evaluate whatever has done here. They check an evaluation here. If the evaluation is like okay, it will go to the end. If that evaluation is not okay, then the model is refined and the parameters are adjusted in this set action center. So to understand it more clearly, let's assume that we have a problem. Like I have to train a dog to catch the ball, to fetch the ball or catch the ball. So the environment is like the playground where the dog and I am right now. So the agent would be me, and I am telling the dog to catch the ball. So this is the set of actions that I am doing. So whenever the set of actions are performed on something, it receives the feedback. If the dog brings the ball back exactly that what I have told him, he will receive a positive feedback. That is a praise. If he doesn't do that, then he doesn't receive a positive feedback. Then he received a negative feedback. So after checking all these feedbacks, what will I do? I will update the policy that if the dog is able to learn this or not. So if if the evaluation to me feels necessary that the dog has learned this all set of things, so then the performance I consider is like it's a good. If the dog hasn't learned how to fetch the ball, so the performance is not okay. So it will be again and again. It will be a trial method, hit and trial method. So the performance is not okay. So we refine the model and we set our actions again and again. So to better understand this, the training a dog to fetch a ball. So I was the agent. The environment was the dog and the area where you play fetch. So the state is like the current situation of dog where the dog is sitting or running. The action would be that the dog would run after the ball, pick it up, and then return to you. So the reward or the feedback would be it receives a treat or a praise when it successfully fetches the ball. So if it does not, so he doesn't receive a praise. The policy that I will update is the strategy that the dog learns to decide which action to take in a given state. If I see the ball, I should run after it. So if the dog doesn't learn it, so we update the policy and you repeat this process like multiple times that dog becomes efficient at picking up the ball. So this is basically how our reinforcement learning, how actually works. Like this is a trial method in which you try again and again to make your model become efficient at anything. So these were the types of machine learning. And now we will look at coding the logistic regression inside a Google Colab laboratory. This is an online environment. It has everything pre-installed. So this basically is a Google Colab environment where you can run your machine learning examples or machine learning tasks. So as you can see that I'm in the first step, I'm downloading some necessary libraries for this task. And the first library is NumPy. So what NumPy does is NumPy is used for like to play with data, like play with arrays. Like you have arrays, you have learned arrays. What is an array? Like array has a data. And there's another library known as matplotlib. So this is basically used for plotting your data. And as I have told you, scikit-learn, this basically imports your data like logistic regression and etc. So first we will do is we will try to run this. You have to connect this. So this is connected to Google Compute Engine backend. So you run this model. This is the requirement is already satisfied. Like I have already installed this. So now I have to import some necessary libraries that I have mentioned it. In Google Colab, you necessarily don't have to like install these libraries. They are like pre-installed in it. So these are like some, I'm importing some libraries, NumPy, and for plotting this and for data sets like sklearn, import data sets. And which data set? This you can see logistic regression. Now I have to load that data set. The data set is a minced data set, and I can show you here what basically my data is. My data is like of 70,000 images. 70,000 images in like these kind of images, which represent some numbers 5, 0, 4, 1, and this basically is a 1. So This is a data set which represents numbers, and I have a label according to this number. So if I have an image of 1, which is like not clearly, so it will have a label 1. So if I have an image 0, it will have a label 0. So this is my data set. Like I am importing my data set. And in this data set, you can see that I have created this X as features and this Y as target, that I have like mentioned it in the logistic regression. Like X would be the feature and that Y would be the target. So sometimes this takes like a few seconds more. And to avoid it, you can always use, in the notebook settings, you can always use a GPU. GPU is recommended over CPU because it's like it is more fast. So if it took 40 seconds in GPU, then it might took like more than a minute in a normal CPU. So I have separated my input features and my target data. So like now I have to plot some data, I have to visualize it. So I would take like a few images that are like 25 images, like 25 images. And you can see this is a 5 image which has a label 5, 0 has a label 0. So basically what I meant was like you have an image and you have a label. So this is basically an example of a supervised machine learning in which you have an image and you have a label according to it. So these are like a few data. So next I have to like split my data into training and testing. So to better understand it, you can see this. Like my data is like 70,000 images. So I have splitted my data into two things, like training data and testing data. So training data is like 60,000 images and testing data is like 10,000. You always split your data 80 to 20. 80 goes to training, and after that you have trained your data, then you test your model on this testing images. So inside my training data, I have an X train. X train basically represent to my images, and Y train basically represent to the labels in this. And similarly goes for the test. X test represents to the images and Y test represent to the labels. So I have splitted my data into X train, X test, Y train, and Y test. Data is like splitted. So the next thing is like I have used a standard scaler. A standard scaler is like this is like imported from sklearn. This is basically used to standardize features like if some images have like variance or mean or standard deviation more than the other have, so the feature will like mix in it. So we have to make a standard for every picture, for every image. So every feature will have a mean of 0 and a standard deviation of 1, like these every images, so they can basically work easily for us. So we have like standardized the scalar features, X train on X images and Y train on an X training data and testing data. So next, what will we do? We will create a model. So this is like we are creating a model. We are calling a model logistic regression, which is basically importing from sklearn. So this is like built in. You just have to call your name of the model. So what will this model fit?
Sorry for the interruption. There is an announcement. The Google form for e-certificates are in the chat. The e-certificate form is active for only for 10 minutes. Thank you.
Okay. So we are creating a model. So this model is fitting the X train, which is the training dataset images and the training dataset labels. So these are the number of iterations that it will make. So the model is like created. Now we have to make predictions on this model. Like this is the model. Why we create the model to predict model.predict on X text. This test means that okay, I have created a model. I have trained a model. So this X test is the images. So I have to train this model on this testing images that I had separated before. So like we can print out the classification report of a model. In this model, we have like Y test and Y predict. Predict is this prediction we recently made, and Y test. So as you can see that we have achieved an accuracy of 0.92. That means like we have achieved an accuracy of 92% in this model, logistic regression. And this is like this, it was run on like 1400 images, 14,000 images, basically not 1400. So this is how you run basically a logistic regression uh, model in your Google Colab. Like it is for like starting. When you move to other data, you may need another model. So as you can see, the data was like the images were like blur because the pixel size is like 28 cross 28. 28 cross 28. I mean, this is an image, and images you would know like these are the pixel in it images. There are like zero values which represent the white one, and there are like these numbers that is like 4, 5, 6, 7 that represent this black one. Like zero is for like white, and the more one it goes, like it will make a darker. So this is how every image can be brought as an array of numbers between 0 to 1 describing how dark pixel is. Like this is the intensity. So this was our data set. Like it had numbers like 5041. This was like a hand digit written data set. So it was basically two parts. This is the image, and we have a corresponding label. Like it would be written like 5. It would be written 0, a corresponding label to the image. So the labels for the above images are like 5041. So the next thing would be the introduction to deep learning. So we basically covered machine learning. We used only one example, but if we go into the unsupervised learning example, it might take a lot of time. So introduction to deep learning, but basically is deep learning. As you know, deep learning, machine learning is basically a subset of AI. So deep learning is basically a subset of machine learning. Like the more deeper you go of machine learning, it is deep learning. So it is almost somehow similar to machine learning. It teaches the computer to learn from the data, like in machine learning. Uh, instead of like we do not program the computer in machine learning to perform something. We only give them data, and from that data, they only learn how to make themselves better. So for instance, if you see a picture of an image, that is cat and that is dog. This basically is a deep learning network, which has deep layers, connected layers. So what we have to do is we have to predict that the output of a cat, that this picture that we have given input to this deep learning model, this is a cat or not. So deep learning is like these deep layers connected to each other. So what would be the difference between deep learning and machine learning? So in deep learning, you saw that we have like features which were like age and smoking diseases and gender. These were like features, like fi written in that data set. They were like features. In machine learning, we have to manually create some features or manually extract some features. For that purpose, we need some data scientist or domain expert that know the feature better, and then they can select from the raw data. But in deep learning, we don't need to manually extract the features. Deep learning models like neural networks, if you have ever heard of it, they can automatically learn and identify and extract important features from that data without human intervention. Like we don't need to manually fill it. The deep learning model will automatically do it. Uh, Deep learning models achieve higher accuracy than machine learning when dealing with like a large vast amount of data. So whenever the data set is like a very big, like it goes to like now we were seeing a 70,000 images, like this was a small data set. If the data set is like of 150,000 images or like 1 billion parameters or like 1 million parameters, so deep learning models are like expert at those. Machine learning won't work there easily. So deep learning generally outperforms machine learning like in every concept. Whether it is like complex tasks that involves unstructured data, and we have like less human interaction in it. Like deep learning models require less interaction because as I've told you, they're like when you are extracting features that are automatically done in deep learning. So we don't need human intervention in it. So this is basically a deep learning model. In this, like previously I shown you the image of cat, this is an input image. So this is where feature learning is done, and this is where classification is done. These are like interconnected deep layers. uh, so in this first step there is convolution going on with pooling layer, convolution again, and convolution again. So to understand it better, we can see from this example. Consider this image of a zebra in which like I'm like trying to only take this feature, like these lines, these yellow lines. So I will pass these lines to the convolution. This convolution will convolve and make it like more smaller. These are like the features of this image. Like we don't we input this image into this convolution model like in small features like this tail and this foot, etc., and this like hairline, etc. So we take like a small feature and we give it to the model. In this model, it performs a convolution, and this convolution goes forward, and it creates a like this image is like a matrix. So it creates a smaller matrix than a smaller, like it's highlight only important features that it learns throughout this model, and after that it flatten this, like this is image, matrix image, then it flattens it like like consider this last image that has a value of 0, this has 1, this has 5, this is 4, this is 1. So these values will go like 1 2 3 4 5 6 7. So this step flattens it before giving it to a deep learning model. So this deep learning model is basically a neural network architecture which has an input values and it produces an output based on the probability of. So like what probability, like probability in probability you have a value like 0 to 1. So between those value, whichever is the highest get predicted as your model output. Like you can see here that for a horse 0.2, for a zebra for 0.7, for a dog 0.1. So based on these lines, it predicted that this is of a zebra. So at the highest probability gets like the output. If this predicted like 0.8 to a horse or 0.1 to this and 0.1 to this, so this means that this machine learning algorithm, this deep learning algorithm is not working. So what will it do? It will refine, it will go back to it, and it will do it again. So this is a process, like it goes again and again until it gives you a better output from it. So what are basically these applications of these deep learning models? So as we were dealing with the images, the images are like a type of a deep learning model that is known as convolutional neural networks, CNNs. So what basically they do, they identify and characterize these images, like previously we have done with mints data. Now we have seen a zebra image. So we can identify what an image is, and we can identify what an object is. What is it like? Is it a fruit, or is it what? Is it a car, or is it something else? We can identify an object from it, and in the image segmentation part, we can like divide our image into smaller segments for the more detailed analysis, like what is going on here. So as you have seen, like you have done like medical MRIs, like medical image analysis. In medical image analysis, the same things happen. Like you focus on some important feature, and you see the more detailed analysis of it. Like you separate it. You the people who have done, like you have who are studying like digital image processing might know it. So this is like a bit advanced thing. So, what are basically the top trends that we have to follow, or we should follow, to keep up pace with this deep learning and machine learning? So, right now, the industry is working on generative AI agents, large language models, generative adversarial network scans. So, you have probably heard of large language models. What are these? Like ChatGPT, Perplexity AI, Claude AI, and etc. So, right now, the deep learning uh, is like mainly and fully focused on these four areas. So generative AI, RAG, AI agents. AI agents are basically those like who perform everything on their own. So large language models, these are like used in natural language processing, NLP. So this takes like a vast amount of data in your input, and based on probability outcomes, it suggests you a different kind of data, like a deep learning algorithm that is equipped to summarize, translate, and predict, and generate human sounding text to convey. The large language model basically gives you a text. So these are like top trends that are working inside the AI industry right now in 2024. So whenever you are working with your machine learning or deep learning projects, where should you code? So the highly rated is Jupyter Lab, and the other is like Google Colab, which I have showed you. And this is these are two code editors. There's VS Code and there's Cursor. The Cursor is one of the most important because it has some AI features in it. So it will help you to solve your code with AI. It will be less, problematic. So what are some of the best resources where you can learn machine learning in future? So basically, there is a website known as Towards Data Science. In this website, you can easily learn machine learning, deep learning, or anything else, etc. Because they are like blogs created for everything: transformer, diffusion, GGUF quantization. Uh, like these are like very advanced topics, but you can also learn like major small ones: deep learning for COP, yield prediction model. Like people have created blogs for it, so this can help in learning. So the next main thing would be like this is basically a course on Coursera, deep learning specialization by Andrew Ng. This is the most famous course in which you learn about deep learning, neural networks, structuring machine learning projects, CNN, basically what I was telling you, improving your deep learning networks, sequence model. And after that, we can see that what is basically a roadmap for to learn this. Someone who is interested in learning AI, neural networks, or machine learning for the future, what he has to go through it. So first of all, he should like learn a bit mathematics, which includes linear algebra, calculus. Then he moves on to statistics. Basic statistic is good to know. If you are like going into data science, then you might need something more of it. So for data science, you might need to know this econometrics. And after moving on, we come to coding part, where you learn Python as a programming language. And after learning this programming language, like you might know, you might get to know like a beginner level or intermediate level. That is fine to know. After this coding, that you have to go to the exploratory data analysis. Like you have to view your data with some different machine learning libraries like pandas and seaborn. After this data analysis, you move on to machine learning, their algorithms, the course specialization course that I showed you. Then after machine learning, you learn deep learning. That's convolutional neural network and LSTM transformers and transfer learning fully connected. After learning this deep learning, you move on to machine learning operations that is based on cloud learning. So basically, this is a guideline or a roadmap, roadmap.sh AI data scientist. So this is officially a roadmap where you can easily learn or you can easily find a roadmap or a way to become a machine learning engineer or a data scientist in future. So this might help you somehow. So basically, this is the end. Thank you everyone for joining this lecture. I hope you find something interesting in it.
Thank you so much, sir, for such an informative session. Now we will moving towards our question answer session. Those who have some questions, raise your hand. I will unmute them and they can ask questions.
Assalamu alaikum, sir. My name is Kashif and my question is कि सर अगर मशीन लर्निंग की तरफ जाना हो तो मास्टर्स इन एआई करना चाहिए या मास्टर्स इन डाटा साइंस अगर किसी का बैचलर्स इलेक्ट्रिकल पे हो?
देखो बैचलर्स अगर इलेक्ट्रिकल पे हो, ठीक है, द फर्स्ट थिंग इज लाइक फाइनल ईयर में you have to like take 2-3 courses that are similar to machine learning. जब तक तुम्हारे 2-3 courses similar नहीं होंगे machine learning के, तो तुम्हें masters में admission नहीं मिल सकता based on what you have learned before. So
Oh,
to better start it, like you have to learn somehow digital image processing तुम्हारा course होना चाहिए, neural networks तुमने पढ़े होने चाहिए, 1-2 courses अगर ML से related हैं तो you can go like towards a master degree. But you can get a job without a master degree. It's not necessary.
thank you so much, sir.
If someone has a question or not,
I guess चैट में है, चैट में क्वेश्चंस आ रहे हैं, चैट में चेक कर लो. हेलो अरबाज भाई, आवाज आ रही है?
हाँ हाँ आ रही है। मेरे ख्याल से ये हसन हुजैफा हैज समथिंग रिटन, व्हाट्स गुड रोड मैप फॉर जनरेटिव एआई। सो जनरेटिव एआई बेसिकली, सो जनरेटिव एआई, सो आपको सबसे पहले तो आनी चाहिए पाइथन, ठीक है, तो ओनली प्रोग्रामिंग लैंग्वेज। उसके बाद आपको डीप लर्निंग के कॉन्सेप्ट्स आने चाहिए, अच्छे खासे, कि आपको डीप लर्निंग का कुछ आइडिया हो। फिर आपको लाइक नेचुरल लैंग्वेज प्रोसेसिंग के कंसेप्ट आने चाहिए, एनएलपी। लाइक जो चैट जीपीटी यूज कर रहे हैं ना, कि हाउ इज चैट जीपीटी इवन वर्किंग ऑन विच प्रिंसिपल्स, ट्रांसफॉर्मर्स में चैट जीपीटी इज वर्किंग ऑन अ थिंग दैट इज कॉल्ड ट्रांसफॉर्मर्स। आपको ट्रांसफॉर्मर्स का पता होना चाहिए, और लॉन्ग शॉर्ट टर्म मेमोरी का पता होना चाहिए, एलएसटीएम का पता होना चाहिए। और उसके बाद जनरेटिव एआई मॉडल्स का पता होना चाहिए। व्हाट आर जनरेटिव एआई मॉडल्स? लाइक GPT-4 है, लामा है गूगल का। और उसके बाद आपको वेक्टर डेटाबेसिस के बारे में पता होना चाहिए, लाइक कि आपका ये जो जीपीटीज वाले डेटाज हैं, ये सारे, ये आपके डेटा स्टोर कहाँ पे हो रहे हैं, व्हाट आर द डेटाबेसिस दैट दे आर यूजिंग, लाइक क्रोमा डीबी और कैसांड्रा डीबी एक्सेट्रा। उसके बाद अगर मॉडल आपका क्रिएट हो गया, आपने मॉडल बना लिया, तो अब आपको चाहिए कि आपने डिप्लॉय कहाँ करना है दिस मॉडल, लाइक ऑन सम ऑफ लाइक गूगल क्लाउड में डिप्लॉय करना है, AWS में करना है, या हगिंग फेस में करना है। हगिंग फेस इज एन ओपन सोर्स फॉर AI models. So basically these are like few things that you should know while learning generative AI. लेकिन उसके पीछे एक थोड़ी हिस्ट्री है, लाइक पहले डीप लर्निंग से और बाकी सब चीज़ों से होकर आना।
सर अरबाज
अरबाज
भाई
भाई,
कोच।
और एक और क्वेश्चन है,
What are
ये
you
आप चैट में
what are your views on Kaggle and practices turnout on it? Is it cool to build the resume? हाँ, Kaggle is a good thing, good website where you can get a lot of like data sets, और वहाँ पे लोगों ने अपना कोड लिखा हुआ सबमिट कराया होता है। लाइक इफ़ यू आर वर्किंग ऑन सम मशीन लर्निंग कोड, ठीक है, अगर तुम स्टक हो गए हो तो यू कैन ऑलवेज कैच अप दैट कोड ऑन द कैगल, क्योंकि वहाँ पे काफ़ी एक्सपर्ट्स ने अपना डेटा जमा कराया होता है। सो इट्स समथिंग गुड। उसके अलावा देर इज समथिंग एल्स, देर इज अ वेबसाइट नोन एज UCI डेटा सेट, लाइक दिस यूनिवर्सिटी ऑफ कैलिफोर्निया समथिंग का कोई डेटा सेट है, दैट इज़ गुड टू गो। और बस कुछ मेजर प्रोजेक्ट्स वगैरह रेज्यूमे में डालो जो किए हुए हैं, दैट्स गुड टू गो। हैविंग अ बैचलर्स डिग्री इन इलेक्ट्रॉनिक्स इंजीनियरिंग, हाउ कैन वी टर्न आवरसेल्व्स टुवर्ड्स द प्रोग्रामिंग डोमेन? So basically I'm an electronics engineer, as you well know. So like I have shifted somehow towards this programming domain. आपके लिए सबसे पहला स्टेप क्या है टुवर्ड्स दिस CS या AI और इन सब चीज़ों में आने के लिए? द फर्स्ट स्टेप टुवर्ड्स इट्स कि आपने प्रोग्रामिंग के रिलेटिव क्वेश्चंस ढूंढने हैं। क्वेश्चंस क्या है, प्रोग्रामिंग के अपने रिलेटिव कोर्सेज ढूंढने हैं। लाइक ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग पढ़ाया जाता है, फंडामेंटल्स पढ़ाए जाते हैं। उसके बाद आपने थोड़े बहुत मशीन लर्निंग के कोर्सेज ढूंढने हैं, बिकॉज हर जगह प्रोग्रामिंग आ ही रही है। और इन इलेक्ट्रिकल इंजीनियरिंग और इलेक्ट्रॉनिक इंजीनियरिंग देयर इज अ लॉट ऑफ प्रोग्रामिंग। आप इलेक्ट्रिकल इलेक्ट्रॉनिक्स में रह के भी प्रोग्रामिंग कर सकते हो, C++ कर सकते हो, मैटलैब पे कर सकते हो, देयर इज अ लॉट ऑफ थिंग्स। इफ आई एम न्यू टू कोडिंग एंड जस्ट लर्न object oriented and DSA in C++ and Python, how should I further pursue in coding, meaning practice my coding to get experience? ओके, उसके लिए ये है कि आप प्रैक्टिस करें। द वन थिंग इज लाइक डेटा स्ट्रक्चर्स एंड एल्गोरिथम इज वेरी इंपॉर्टेंट इन दिस कोडिंग एक्सेट्रा। इसकी लाइक काफ़ी ज़्यादा प्रैक्टिस वगैरह करें। लीड कोड का आपने नाम सुना होगा, लीड कोड पे आप अपनी प्रॉब्लम्स देखें, ईजी, मीडियम, हार्ड, और वो आप लीड कोड सॉल्व करें। द बेस्ट थिंग वुड बी कि आई वुड सजेस्ट यू शुड लर्न अ फ्रेमवर्क, whether it's a website framework or whether it's a machine learning framework. Like whatever you are learning, you should implement those things into building some projects. So वो projects जो होंगे वो आपको future में help करेंगे to get a good job somewhere. Or there is a guy, Abdul Rafi, he said something at a great session today. As a mechanical engineer with a passion for machine learning, I'm struggling to find software houses in Islamabad where I can apply for internships. Could you guide me on the requirements and how to apply for these opportunities? So Rafi, the thing is that firstly you have to build your profile, CV और resume, ठीक है? और resume में तुम्हारा टाइटल मैकेनिकल इंजीनियर नहीं होना चाहिए, ठीक है? because you have a passion for machine learning. तुम्हारा टाइटल मशीन लर्निंग होना चाहिए, बेशक क्वालिफिकेशन में तुमने मशीन मैकेनिकल लिखा हो, ठीक है. द नेसेसरी स्किल्स रिक्वायर्ड वो तुम्हारे आने चाहिए, ठीक है. तुम्हारे कंसेप्ट वगैरह क्लियर होने चाहिए और सब कुछ तुम्हें बताओ. और इट्स बेटर टू गेट सम लाइक एक दो सर्टिफिकेशन ले लो कहीं से, बिकॉज दिस सर्टिफिकेशन काइंड ऑफ हेल्प अ लॉट. और इंटर्नशिप मिल ही जाती है. लाइक यू हैव टू अप्लाई. तुम्हें देखना है कि तुम किस जगह पे अप्लाई कर रहे हो. इंटर्न वाले रोल पे अप्लाई कर रहे हो. इंटर्नशिप्स वैसे खुलती मोस्टली समर में ही है, लाइक जून जुलाई में. अगर तुम्हें वहाँ पे इंटर्नशिप नहीं मिल रही, इफ़ यू आर रियली इंटरेस्टिंग इन डूइंग सम इंटर्नशिप्स, तो तुम अपनी यूनिवर्सिटी में देखो ना. लाइक आई न्यू, मैं जब फाइनल ईयर में था, आई वाज डूइंग एन इंटर्नशिप इन द स्वाम रोबोटिक्स लैब दैट आई मेंशन्ड. डॉक्टर नवीद के साथ वहाँ पे थे. ही इज़ अ टीचर इन लाइक कंप्यूटर डिपार्टमेंट. सो तो आप वहाँ पे कर सकते हो. आप पूछ सकते हो, आप किसी भी सोसाइटी में कर सकते हो. इट्स बेटर टू कैच अप.
So now we are done with the queries. It's time to wrap up this amazing webinar. Sir, is there anything you gonna say before we conclude?
I want to say something like this was a great webinar for the students. I feel like this is like a beginner level thing to jump on to things that are like big. So if anyone has a query or anyone has some problem, Kaf and Zan, you can give them my LinkedIn. They can like text me there if they have any query related to coding or related to any profession opportunities. Like I can guide them to my best.
ओके अरबाज, इसके अलावा ये कि हम लोग ट्राई करेंगे कि फ्रॉम मूविंग फॉरवर्ड हम लोग इस तरह की इस क्लासेस को आगे लेके चलते जाएं एक स्टेप बाय स्टेप. और नेक्स्ट अगर वेबिनार हम लोग अरेंज कर सकें तो हम नेक्स्ट स्टेप की तरफ जाएं जिसमें हम लोग मॉडल ट्रेनिंग के साथ साथ उसकी डिप्लॉयमेंट वगैरह की तरफ भी टच कर सकें.
हाँ हाँ, लाइक हाँ, नेक्स्ट हम अगर करना चाहें तो वी कैन लाइक डिस्कस डीप लर्निंग इन डिटेल. बिकॉज
यस,
वो उन लोगों के लिए होगा ना कि लाइक दोज हु आर वर्किंग इन डीप लर्निंग. आई कुड हैव गॉन टू डीप लर्निंग नाउ, बट इट इज लाइक a bit complex, not a beginner friendly. So yeah,
बिल्कुल.
I'm on.
ये है कि आप लोगों में से जो जो मशीन लर्निंग में न्यू है, आप इन सारी चीज़ों को लें, इंफॉर्मेशन को. अभी आपसे स्लाइड्स भी शेयर हो जाएंगी ग्रुप में. और प्रैक्टिस करें, प्रैक्टिस करते रहें. और नेक्स्ट टाइम जब नया वेबिनार होगा तो हम आप सबको इन्फॉर्म कर देंगे. और इंशाल्लाह उम्मीद है फिर तब तक आप लोग नए कॉन्सेप्ट्स भी ले सकेंगे. तो जैन, आई गेस वाइंड अप कर लो.
Thank you so much, sir, for honoring us with your presence. Your knowledge has really uplifted the bar. I would also like to thank our attendees for becoming the part of this amazing session. Hope you guys learn a lot throughout the event. Stay blessed and positive. Take care. Allah Hafiz.
Thank you. Allah Hafiz.
हाफिज़ एवरीवन.